This is ACT Math Prep video number 4. You'll have 7 questions in your 8 minutes. So as usual, have somebody set their phone or a timer for 8 minutes while this is paused. At the conclusion of those 8 minutes, we'll start the video again. Our content for this one is geometry. You'll be doing number 44 to 50. Number 44, we're looking for how many square feet are on this window, which means we're going to be finding the area. We have a rectangle topped off by a semicircle. So we're going to need to do the area of the rectangle plus the area of the semicircle. I'm just going to draw a picture in order to get the area of the entire region. One thing to note though is this says square feet and we are given the dimensions in inches. So what we need to do first is a little conversion here. You could do it at the end, but you run the risk of, for example, if for this one you got letter E, that's how many square inches there are. So that's actually wrong. It means you did the right work, but you didn't convert. And a lot of people will say, well, just divide by 12. But you have to be very careful with that because a square foot is a 12-inch by 12-inch plane. And so it actually has 144 square inches in it. So if you had this, you'd have to divide it by 144 to get square feet, which would give you the right answer. But most times it's easiest to convert the dimensions before you even start. So we really have a 1-foot radius and a 4-foot height. The area of the rectangle is length times width or base times height. So it's going to be 4 times this, which is going to be 2 feet because there's 2 radii that stretch across that. So 4 times 2 plus the area of the semicircle. The circle's area is pi times the radius squared, and we have to have half of that. And a lot of times when I say what's the area of a circle, people will say 2 pi r. That's circumference or difference around. Around is squared, distance around. The area of a circle is pi r squared. The way I remember that is when you label area, you say like 58 square feet or square inches. And so area and the squaring go together. This is circumference. So be careful with that common mistake. When you do this on a calculator, 8 plus 1/2 of pi or pi over 2, the 1 squared is just 1, so no need to enter that. You can use your pi button or 3.14. These are far enough apart answers where you'd still get the right solution. You'll have 9.57 square feet for that window. On number 45, we have a circular cone. You're not expected to have that formula memorized. You should know the volume of a cylinder. That you should know for sure. The volume of a cylinder is the area of the base, pi r squared, and then you give it its height, and it's pi r squared times h. A cone actually takes up 1/3 of the space, it's 1/3 pi r squared h. So the volume of the cone is 156 cubic centimeters, and it has a height of 7, and we're being asked to find the radius. So I have to isolate r. Instead of isolating it and then going to your calculator, I go to your calculator right now and isolate it as you go. It's safer and it's faster in a question like this. So enter the 156 on your calculator and systematically wipe these out on the left. So how do I undo division by 3? I multiply both sides by 3. So go to 156 times 3 on your calculator and just hit enter. To undo multiplication by pi, I'll divide both sides by pi. So now divide that last answer by pi. To undo multiplication by 7, I divide by 7. So divide your continual answer now by 7. To undo squaring, I take a square root. So whatever's left on your calculator screen, take the square root. In doing so, you'll get D, 4.6. That's safer and faster than isolating it and then going to your calculator. You might have had the right answer though if you said, okay, I'm going to multiply both sides by 3, gone, divide by pi, gone, divide by 7, gone, take a square root. But the problem with this is the entry all in one chunk is much more difficult than if you just kind of keep it running as you go. Number 46, we have some alternate interior angles. Interior mean inside the parallel lines, so 3, 4, 5, and 6 are interior. 1, 2, 7, 8 are exterior. Alternate interior means opposite sides of the transversal. 3 and 6 and 4 and 5. Sorry. And their angles are congruent if you needed to know that. But 3 and 6 are alternate interior. 1 and 8 would be called alternate exterior, and they are also congruent. Again, the ACT will ask you a question about these relationships. It might not be alternate interior, it might be about the exterior. Might ask you about corresponding angles. Those are in the same spot in their clumps of 4. So angle 2 in the top right corresponds to angle 6 in the top right. They are also congruent. So again, they can't ask you everything. They'll ask you at least one question about alternate interior, alternate exterior, corresponding, and I don't know that they'd ask you consecutive interior. Number 47, we have a circle with a circumference of 36 pi. Distance around, that's what circumference means, and that's 2 pi r. It asks you for its area. Area, thinking of, again, square feet, square inches, is pi r squared. For me to get that area, which is what I'm looking for, I need the radius. So let's go attack the radius with this equation. Divide both sides by pi, and I get twice the radius has to equal 36, which means my radius is 18. That can now get plugged in for the radius. Now, again, always keep your eye on the answers, or you're going to waste some time. My answers have pi in them. We call that in terms of pi. So what that means is leave pi in here. Do not put it on your calculator. All you need to do is figure out what 18 squared is. And 18 times 18 is 324. The pi stays in your answer for an answer of D. Number 48, which is not true. So test taking strategy, the minute you find one that's not true, move on to the next problem. Is every rectangle a parallelogram? Rectangles look like this. Opposite sides are parallel. That's the definition of a parallelogram. So yes, every rectangle, oops, I shouldn't circle that. Yes, every rectangle is a parallelogram. A quadrilateral is a four-sided polygon. Every quadrilateral is a polygon. That's true. Is every trapezoid a parallelogram? Well, here's an example of a trapezoid right here, and you can see a trapezoid only requires one pair of parallel sides, not two. So this one is not true, and I would move on to the next problem. But because we're doing review, I also want to discuss these two. Is every square a rhombus? Here's a square. All sides congruent. And it has to have 4 right angles. Is this a rhombus? Well, what's the definition of a rhombus? A rhombus is a quadrilateral that has to have all 4 sides congruent. That's it. A lot of times we think of your general rhombus as kind of looking like a diamond. All 4 sides are the same. Is a square a rhombus? Does it have all 4 sides congruent? The answer is yes. The converse of that is not true. If it's a rhombus, must it be a square? Well, no, you can see you don't need to have 4 right angles to have all the sides the same. Even I can draw one that's really auto-whack and obviously not a square. But every square has 4 congruent sides. All parallelograms are quadrilaterals. That's true because they have to have 2 pairs of parallel sides. They'll have 4 sides, which is the definition of a quadrilateral. Number 49, we are looking for the perimeter, which means we need to figure out what this side is. So what we're going to do is drop down a altitude or a height. Know that it is also 4 because of this over here. And I just need to figure out what x is. And you should, every time you see that right triangle, you should think Pythagorean theorem. I can't figure out what x is unless I know this. And they must have given it to me. Not directly, but if I know the whole way is 13, and from here to here is 10, consequently, this would have to be 3. So right now, in a higher level, you should recognize that as a Pythagorean triple. It's the most common one, the 3, 4, 5 triple. So hopefully you just know, hey, that's 5. But if not, you have to do your Pythagorean theorem and do it the long way. 9 plus 16 is 25, and you'll get 5 for the length of that side. Now, it doesn't ask me for the length of the side. It says the perimeter, so I have to do 5 plus 10 plus 4 is 19, plus 13 is 32. So again, you're not going to finish if you don't know some of that like special right triangle stuff and knowing that 3, 4, 5 completes the Pythagorean triple, but you can still get a lot right if you default to ways that will take you longer. The last one up here, number 50. We are given KNM. KNM is 40. I'll put that on there. NKM, and here is 115. I'm going to stop right now and go get this one just because I can and I'll probably need it. Inside a triangle, I have 150 degrees already with these two. Removing that from 180, 155, removing that from 180 gives me 25 degrees for this one right here. It asks me, what's the measure of JLK? That's this one. Well, from geometry, when an inscribed angle like this one that hits on the circle cuts off this same arc as another inscribed angle, they both cut off arc JN, these angles are congruent. Okay, so if that's 25, this has to be 25. So angle JLK is also 25 degrees. Before I quit though, although this one's asking you about those inscribed angles, that's like when I go like this, and I'm hitting on the circle, the relationship between the angles and the arcs is often asked on the ACT as well. So if this is a 50-degree angle, the arc that it cuts off is actually double it. We say the inscribed angle is 1/2 of the measure of the intercepted arc. If it hits in the circle though, what we have is they're equal. So a central angle is equal to its intercepted arc, and an inscribed angle is 1/2. The ACT often has questions about those, so I'm going to repeat them. If I have this, and I cut that off, and maybe they tell you this is 60 degrees, what you now know is this is 30 degrees. It's 1/2 the arc. However, if it hits in the center, and I tell you this is 60 degrees, then the central angle is also 60 degrees. So it's a very common relationship you'll see on the ACT. So actually, had they asked me what the measure of this arc is, it's 50 degrees, because it's double the inscribed angle. Wasn't asked, but we are done. Have a good one.